Hi everyone. In this video lecture of the emittance audiometry series, we will be discussing about how to record a tympanogram. By the end of this lecture, B.ASLP students will have an overview of how a tympanogram is being recorded during emittance audiometry. Tympanogram is a graphical representation of the tympanic membrane's compliance as a function of ear canal pressure. However, the admittance is what is being recorded or measured during the tympanogram measurement. This is a pictorial representation of our ear canal along with the tympanic membrane, middle ear space and the cochlea. The probe of the tympanometer consists of various components to record the tympanogram and the reflexes. So the major components are a probe tone stimulator or a loudspeaker that emits the probe tone, a microphone to measure the sound pressure level that is present within the ear canal space. There is a pressure pump attached to the manometer, and a reflex activator, a second loudspeaker that is present inside the probe, which will activate the reflex, acoustic reflex pathway of the auditory system. To measure a tympanogram, we always require only three transducers: the probe tone generator or the loudspeaker, microphone, and the pressure pump. A probe tone is generated, mostly it varies between frequencies around 226 Hz or 678 Hz, 1000 Hz probe tone. This is generated in such a way that a constant probe tone is always maintained in the ear canal. So when the sound is being delivered into the ear canal, the tympanic membrane starts to vibrate, thereby conducting the sound from the ear canal to the middle ear space. The tympanic membrane usually vibrates within a boundary of free movement. So the disconnected line shown in the image depicts the maximum extent at which the tympanic membrane can vibrate. During this vibration, the sound from the ear canal enters into the middle ear space. If the tympanic membrane is not vibrating, or if it is more stiff, or the compliance is reduced, the sounds will get reflected back into the ear canal space. The microphone is used to measure the sound pressure level present in the ear canal wall. It is connected to the automatic gain control. This microphone and the automatic gain control will try to maintain the constant sound pressure level in the ear canal space. The sound enters into the middle ear, the sound pressure level in the ear canal drops. This is picked up by the microphone and it sends the information to the automatic gain control, which will increase the gain of the probe tone stimulator. So a constant SPL is maintained in the ear canal. However, if the tympanic membrane is not vibrating, if it is more stiff, then the sound is reflected back into the ear canal, which will increase the sound pressure level in the ear canal. Now the microphone picks up this change and sends the information to the automatic gain control, which will reduce the gain so that a constant sound pressure level is maintained in the ear canal. The pressure pump is used to deliver a amount of pressure in the ear canal, thereby manipulating the position of the tympanic membrane. For example, when a positive pressure of 200 decapascal is delivered in the ear canal, this positive pressure will push the tympanic membrane towards the middle ear space. In the same way, when a negative pressure is provided in the ear canal, the tympanic membrane is pulled towards the ear canal because of this negative pressure. Now, these two pressures are the extreme points to measure the tympanogram, at least the conventional tympanogram, where the tympanic membrane vibration is very minimal or negligible. So that boundary is depicted by a incontinuous line over this image. Now, in a tympanogram, as a tympanogram is a graphical representation of the tympanic membrane movement or the compliance of the tympanic membrane or the admittance of the sound through the middle ear space, the x-axis will have the pressure. So that is unit of pressure is decapascals, and the y-axis is the ear canal volume changes that happens during this movement. So how much of vibration is happening or how much of sound is that is entering into the middle ear space. That is mentioned as a compliance or admittance. The unit is ml, milliliter, or the cubic centimeter or centimeter cube. Now, to measure the tympanogram, initially a positive pressure, a full positive pressure is provided in the ear canal space. This will push the tympanic membrane to the extreme positive side towards the middle ear space. So at this point of time, there is virtually minimal vibration of the tympanic membrane. So only lesser amount of sound is being conducted into the or admitted into the middle ear space. Most of the sound is reflected back. So that microphone that is picked up by the microphone, automatic gain control works, the volume flow is detected, and the admittance is measured for that particular pressure. When the pressure is reduced to plus 100 decapascals, now the tympanic membrane is free to move from the maximum extent to this particular extent at which the tympanic membrane portion is held. So this vibration will allow the sound pressure level from the ear canal to enter into the middle ear space. So better amount of sound is admitted into the middle ear. At 0 decapascal, the tympanic membrane is at its natural position. So more area, more space is available for the tympanic membrane to vibrate for the sound. So more sound is admitted into the middle ear space. So the admittance increases. As we reduce the pressure in the ear canal to minus 100 decapascals, the tympanic membrane is pulled towards the ear canal, restricting the movement of the tympanic membrane. Now the space in which the tympanic membrane can vibrate or move is reduced compared to the 0 decapascal position. So this will result in the reduced admittance. Further change in negative pressure will cause more sound to be reflected back into the ear canal. So lesser amount of sound is being admitted. So the admittance decreases. Like this, at minus 300 dapa, again the admittance decreases. At minus 400 dapa, the extreme end, where there is virtually very limited movement of tympanic membrane, most of the sound is reflected back into the ear canal, very less amount of sound is being admitted into the middle ear space. Now all these data points, how much of sound is being admitted into the middle ear, is plotted with respect to the different sound pressures, the pressure level in the ear canal. Now these data points are interpolated to get the tympanogram. Based on the parameters of this tympanogram, the peak pressure, the static compliance, and the ear canal volume, we can detect various middle ear pathologies. So from this video lecture, we have understood how a tympanogram is actually being recorded. Please refer to the books so that you will be able to understand the concept much better. Thank you.